Hello everyone, today we are with Donatella Firmeni, researcher at Sapienza Università di Roma, to talk about the inGraph tool. How would you describe what the inGraph tool is?
Hi everybody. So let me just introduce briefly the inGraph tool within the Intense project. inGraph is basically the foundation of the neurosymbolic intelligence of the project, and it consists of a graph database, basically, storing facts and in terms of entities and relationships in the domain of the cloud computing and the use case applications that we are working with in Intend. So technically, let me just say what a fact is. So a fact here is a predicate. Indeed, we call technically this database as a knowledge graph database. So knowledge is facts, and facts are simplified predicates about the world. So it could be that a server, an entity, okay, does provide a certain latency in certain conditions, and all those conditions can be described indeed as simple triples, like subject entity, relationship, and object entity. Then you can have properties and other useful metadata that we are collecting during the Intent project to make everything work smoothly.
What role does this tool play within the Intent project?
So technically, as I said, is the, let's say, foundation of the neurosymbolic intelligence. So what does it mean? It means that tools and use cases have access to this database. So access means that they can upload and download and in general query, make informative queries to the graph database about the facts that they need to for interpreting user intents and taking decisions across several stakeholders. Even more in detail, we currently are testing this capability of querying and the effectiveness of it with tools that are in our work package, meaning, for instance, we have the inSwitch tool, the inChat tool, and the iExplain tool. So in practice, we have the inChat tool that is now interfacing with the user, so taking the natural language query, and then is querying inGraph to disambiguate it in practice. So if you are referring to a certain component of an application, which is the component of the application, then you will find it as an entity and relationship set in the inGraph tool so that you can disambiguate. Human language is inherently ambiguous, so that's why, so let's say the neuro part is the large language modeling, the symbolic part is the facts and entities that are used for grounding what is said and taking. Now we need to go from the ambiguity of the natural language text to the non-ambiguity of the formal language. So that's exactly the bridge that we want to, the gap that we want to fill with the inGraph. So inChat is doing the disambiguation thing. iExplain is basically providing the traceability of every step for the interpretation of the user intent, and the inSwitch tool is using the facts that are stored in the inGraph knowledge graph for making translation of the natural language intent into a non-ambiguous format that can be leveraged by other tools downstream for making cloud continuum operations.
What progress would you highlight in the development of the inGraph tool since the start of the project?
The challenging part when you have to now build a knowledge graph, now you have two sides of the coin. So on the one hand, you want to take the data. So you want really to find the actual data that you want to load. And that comes, let's say, first. But then as you get the data, and we do work closely with the use cases, more specifically, so far we worked with the fill use case and with the gate use case. And so as soon as you can get the data, you need to build a model of the data. You cannot just throw everything, because you need to somehow highlight what are the main, I mean, in part you could, but it's better to have some, let's say you do no, you find some equilibrium of it. And so you have to decide really what are the main entities that requires let's say a modeling effort. So when you do the main entities, you have to picture in mind what will be the workflow of the data. And the workflow of the data does not become clear until you actually start using them. So it's sort of a cycle, no? So everything is interdependent, and so you go through refinement iterations. So actually, after this time, other than getting the data for 2 use cases and validating one, okay, so one is currently validated in the sense that experts are really seeing what they intend, how their intent are interpreted and saying yes, no, that's good, that's great. So other than getting the data, we also were able to build a comprehensive model. So we call it the intent ontology. And this ontology that has been carefully designed, looking at the data, working with the experts, trying to work with them, fixing whenever things are disaligned, that has been written in a paper and submitted to a journal, to a high-quality journal. And that's now in revision process, peer review, and we'll have some results soon. So let's say the 2 main results so far are the validation, that's an empirical result, and the ontology, which is a more modeling result.
What outcomes does Sapienza expect to achieve by the end of the project?
So by the end of the project, we expect to, let's say, finalize the ontology, and that will also be useful to have the reviews back, because peers will have comments, and validating more use cases. So not just the field use case. For Gate, we are working, but we want to go through validation. We want to obtain validation and connecting more tools. So currently tools are in the work package 4, but now we anticipate that also tools that belong to other pillars of the intent will need to interact with the knowledge graph. So let's say more use cases, more tools, and more theoretical depth from the ontology point of view.
Okay, thank you so much for accepting this interview, and see you next time.